In this video, I'm going to show you how you can use code coverage with a normal website. Normally, people use code coverage with PHPUnit to see what code is covered by their tests, but I'll show you how you can use that for websites as well. We start with Xdebug's website running with PHP-S, PHP's built-in web server, which I've started here on the command line. In order to collect code coverage for running this website, we're going to have to do a few steps. First, we have to put Xdebug in coverage mode. Secondly, we need to collect coverage information for each request that we make. And thirdly, we need to aggregate all of these generated coverage files together to render our output. As first step, we need to put Xdebug in coverage mode. We do that by setting its mode configuration setting. Now we can click around in our browser and request pages. However, we are not actually collecting coverage information, we're just put Xdebug in coverage mode. To collect coverage, we're using the same library that PHPUnit internally uses to collect code coverage information. PHP's unit php-code-coverage, which we're requiring here with Composer. I don't have Composer in my path, so I have to prefix it with PHP here. Let's run this command. Although we've now downloaded the library, we still need to make use of this. For this, I've created a small script. In this script, we're setting up code coverage to record the information for what we want. Let's go through what we're actually doing here. First, we're loading the library. Secondly, we're using some uses to make it easier to refer to specific classes. Then we're setting up a filter. A filter makes sure that we're only collecting information for the files that we want to collect code coverage for. In this way, we're excluding the vendor directory for which we're not really interested in. With this filter, we set up our code coverage object. We start code coverage collection by calling the start method. As its argument, it usually wants a test name, but for our instance, we're using the request URI. Now what we want to do is that at the start of each request, we start coverage, but at the end, we want to store the coverage that has been collected to a file. In order to do that, I've set up a shutdown function called save coverage to do exactly that. The shutdown function that's being set up here gets triggered at the end of the request. In our save coverage function, we're referring back to our coverage object, which we unfortunately have to use as a global here. We then call coverage stop, and then we create a PHP report, which basically is a dump of all the information in a serialized PHP file, and we store this in a path of our choosing, temp path crawler, with a unique and random name, so that we then later can merge them together. Normally what I would do is to set up a auto-prepend file to load this file. But unfortunately, auto-prepend files don't work with PHP's built-in web server which we're using. So I'm going to have to hack our router to actually include this file. I'm going to make sure that we actually have loaded the correct file here. Although we get a bunch of errors, it actually worked because you can see that we get a notice on our save code coverage file, which is sort of what we were expecting here. Now let's start PHP's built-in web server again and collect some code coverage information. In the lower right, I have a terminal window that lists all the files that are being created while we click through our application. As you can see, files are being created. Our third step is now to merge this information and actually generate some code coverage output. To merge this data together, we use another project from PHPUnit, PHPCov, which we'll download from their website. This tool is provided as a FAR, but there's also other ways of finding it. The PHPCov tool can take all the files that we have created and then generate a final report after merging all this information. For that, we use the merge command. And as output, we use --HTML within the location where we have our report, and then provide a path where we have collected our information. Now let's run this. If we now open this path in our browser, we can see the output. As you can see, our coverage information doesn't look particularly very good. Let's see which things we have missed. For example, it highlights the CI controller as not having any lines covered. For example, you can see that our CI controller hasn't been run at all and that our home controller only has covered about 31%. Let's dive in here. you can already see sort of in the first section which route we haven't covered. For example, the updates page or the license page hasn't been shown, or the download page. Let's go to our download page to see that coverage shows up for that as well. Now we have requested the page, we need to remerge our code coverage information, for which we'll use the same merge command. Now when we reload our code coverage page, the download link should light up as green as well. It has done that, as well as the get all downloads model and get latest downloads model functions as well. Besides seeing which methods have been covered, you can also scroll down to see which specific lines of code have been covered. As you can see, we haven't covered the updates or license methods yet, but we have covered every line in get all downloads model. Of course, there are plenty of other things to go through here as well, but I'll end this video saying that this is a very interesting way to figuring out which code is actually used when going through all the URLs that make up your application. It can sometimes be really useful to find out exactly where there's that code that you're no longer using. But of course, you do need to make sure that you actually hit every single URL that is still active. I hope you enjoyed this, and I'll see you at the next video.